How things going with you?
Going pretty good.
Good. So what are we working on today?
Honestly, we're just reviewing for the test, and I'm feeling pretty good about it. I don't really have anything questions about anything that we worked on this unit. So going over SAT would be probably more beneficial.
All right, let's do it. Let me figure out. Last time we got to number 16.
All right.
Okay. 16 at the top left. Here, let me blow this up a little bit. All right, you should be able to see that. All right. T squared minus 4 equals 0. Solve that.
2.
It's plus or minus 2, but because they tell you t is greater than 0, it's only the plus 2.
Yeah.
Okay. 17. Basically two similar triangles. Actually, everything you need to solve this problem, and this is always going to be the case, well, not quite, I guess, is in the drawing. There are some things that are in the paragraph, the 1800, the 1400, and the 700. But that's all. Everything else is showed to you by the drawing. The fact that angle E is equal to angle D means what?
Means they're similar triangles.
Yes. In other words, that means DC is parallel to AE, and it means that angle A is also equal to angle C. You have 3 equal angles. You have 2 similar triangles. So, if AB is 1800, EB is 1400, and BD is 700. It's the similarity ratio. In other words, I could draw it, but I'll point it out. AB, this line here, you can see where I'm pointing. That's 1,800 feet.
Oh, A, B, and B, C.
EB, this side of that triangle, is 1,400 feet. BD, that side of the triangle, is 700 feet. That gives you enough information to figure out the similarity ratio. What's the similarity ratio?
2 to 1.
Okay. And then finally, CD is 800 feet. What's AE?
1600s.
Yeah. Notice how simple the problem would have been if I'd merely drawn two triangles and said they're similar, that's X, that's 800, what's X if it's 2 to 1? And in other words, it's really an easy problem. What makes this problem so hard is that the paragraph is 8 sentences long, and you have to read the paragraph and figure out how to label the picture.
Mm-hmm.
In other words, this is not a hard problem at all. You would never miss this problem except under a speed test where you might be trying to go too fast.
Mm-hmm.
Or you might just say, screw it, this problem's too tough, I'm going to go to the next one. Well, this is really an easy problem. That was 17, wasn't it?
Yeah.
So we need to go to 18. All right, let me do this. How are you going to solve 18?
System of equations, so we can just solve them.
What's the best way to solve it?
Let's solve the top equation by -1.
By the best way to solve it, I mean, do you want to use elimination or do you want to use substitution?
Elimination.
Okay. Once you decide to do elimination, which variable are you going to eliminate?
X.
How are you going to do it?
Multiply the top or bottom equation by -1.
Oh, that's what you meant. Okay.
Yeah.
You don't necessarily have to do that. In other words, you can always subtract equations as easily as add them.
Okay.
Well, I could just subtract the two equations and X is going to go away, right?
Mm-hmm.
The only problem with subtraction is that now I got y minus 2y, which is minus y, and I've got minus 9 minus a minus 25, which is 16, which gives me y equal -16. In other words, when I subtract these two equations, it gives me a lot of chance to make math errors because there's so many negative signs. So I don't mind your suggestion to multiply the top by -1, which gives you this. And now, when I add the two equations, let's make sure I get the right thing. Those go away, and I get y equals -16. So you're doing one extra step, but you're ensuring that your answer is going to be more likely correct, I think. I've never met anybody yet that was as accurate dealing with negative numbers and subtraction as they are with addition. You know what I'm saying? It's just a fact of mathematics that you're always going to be better at addition. All right, one of the few trig questions on the new SAT. On the old SAT, you would not have found any trig questions. But now trig is part of Common Core starting from geometry. So you get a little bit of trig in geometry, you get more trig in algebra 2. You probably haven't reached your trig portion of your algebra 2 class yet, but you should know enough about trig to be able to answer this. Let me show you how to do this. Draw a triangle, always a right triangle, excuse me, and label X. And they've told you that the sine of X is 450, or 4 over 5, excuse me. Dimension this triangle as much as possible. What's that?
Oh, X is a 4 or 5, okay.
Okay, so that's 4, that's 5. What's this side down here got to be? You don't even need to know that side, excuse me. Notice that this angle right there is 90 degrees minus X, correct? Regardless of what X is?
Mm-hmm.
It's always complementary to that angle. So what's the cosine of that angle?
Four or 5?
Yeah, same thing. So there's actually another principle in trig that says the sine of X is always equal to the cosine of 90 degrees minus X. That is a property of cofunctions, cosine being the cofunction of sine. Now, this is actually a fairly difficult problem for somebody that hasn't had a trig course, because in all of this preliminary trig that they teach you, they don't really teach you this cofunction property here. However, you can still solve it by doing what I suggested, which is drawing a triangle, labeling X, and labeling two sides of that triangle. And then knowing that that angle is always complementary to that angle, so it's got to be 90 minus X. And then you can solve the problem. You don't even have to recognize that this has to be a 3, 4, 5 triangle, which means that side has to be 3. But that's actually immaterial to the problem. It would have really been a better problem if they'd have said sine of X is equal to 4/7. What's the cosine of 90 minus X? Then they'd have made it a harder problem, because then you would have almost had to know this cofunction property. Oops. All right. Let's see. A is equal to 5 root 2. 2a equals square root of 2x. Solve for x. Give me an equation to write.
You can substitute a in the bottom equation for 5 root 2.
Good. What do you got?
10 root 2 equals root 2x.
What's the next step?
Where are both sides?
Good. What's the left side become?
Left side becomes 2x.
Left
Oh,
side.
the left side becomes 100. Oh, 200, right?
Uh-huh. In other words, you have to square both terms, so it's 100 times 2.
Yeah, and then the right side would be 2x.
Right. So x is 100. Okay. You'll notice that the problems that are on the grid portion, not very tough. Every one of these was really easy. Maybe not 19 so much, but 19's easy if you know much about trig.
It's been over a year since I did any trig.
Yeah, so. I know. That's why I know that the trig portion is, that's a hard question for a trig question for people who have had minimal trig. You're probably going to get that trig relatively soon. I think that in Algebra 2, they give you a healthier dose of trig maybe midway through the second semester. You're almost there.
Mm-hmm.
So I expect you'll get that trig soon. When are you taking this test for the first time? The SAT?
The SAT, April 5th, April 11th.
I'll bet you have that trig before then. For that reason only. Now, this is the calculator portion of the test. So inherently, we're going to expect these questions to be a little tougher. They're not necessarily going to be questions you can solve all of it in your head. Do you have a calculator in front of you?
I can get one.
Yeah, why don't you? In fact, try to get the one that you'll use during the test. If you have one that you know is allowed, I'm not sure exactly how they do the new SAT, whether they give you an online calculator or they give you some sort of a minimal calculator. No, they don't let you just take in a TI Inspire. You know,
yeah, that's what
factor stuff. All of these equations you're looking at here, you're going to see. They're going to give you these. So you don't have to memorize any of these. But it's important that you understand each one of them.
Yeah.
I think you do. Okay. Number 1.
That's going to be 40 to 60 feet.
Well, from 40 to 60. Strictly increasing, then strictly decreasing. Very good. You did something I didn't do on this. I looked at the 3 line segments and I couldn't figure out which one was strictly increasing and then automatically decreasing.
What I looked at was the intervals that it was giving me.
Yeah, that's the secret.
The ones, because you have to look at the last one could be it, but it doesn't actually go to 70 to 90. It goes.
Well, the last one really couldn't be it because it's increasing and then stays the same for a while and then it's decreasing.
Yeah, so it has to be
Same with the first one. In other words, the first or the last one really could not be it. The only answer that it can possibly be is from 40 to 60 because it says strictly increasing, then strictly decreasing, which means it has no time to be flat. All right. Number 2 is about direct relationships. In other words, y is directly related to x because y is equal to k times x, where we don't know what k is. What's the first step in this problem? Solve for k.
Yeah, solve for k. So you can set y 24 is equal to 6k. And then you get 4k is equal to 4.
So now you have a new equation. Here is your specific equation for this problem, y equal 4x.
Well, you can replace x with a 5. Since it's asking to ask for solve for y, when it's asking for x equals 5, so it'd be 20.
Yeah. The secret on these is always to solve for k. And let's talk about that a little bit. There's two ways that something can be related. Either y can be directly related to x, which means that, or y can be inversely related to x, which means that. And that's really the only two you have to know about. And they always give you an x and y, which allows you to solve for k. And then once you've solved for k, you can answer their second question. But you always need to solve those for k first. Number 3, I see lots of parallel lines. Well, parallel lines, you better know how to handle parallel lines on these tests because you get tons of questions about them.
Subtract 35 from 180 and you get 165, so the angle 2.
Hold on. You did that in your head and you made a mistake.
Yeah, I did make a mistake. It's
Notice that if you looked at the answers first, you wouldn't even have had to do the math.
Yeah,
It's got to be 145.
Well, it has to be. I don't know why I said that.
So sometimes not doing the math is better than doing the math. Because very, very frequently they give you answers that are really far apart. In other words, you know the first 3 can't be right. So I don't have to do the math to know that the 4th one is right.
Okay.
Number 4. Tell me how to write the equation. 16 plus 4x, what comes next?
Is it saying that's equal to 24?
Yep. The is means equal. And 10 more than 14 is 24. Now it's easy. 4x equals 8, x equal 2. So it's all about how you translate the words into an equation. Oh, excuse me. What's the value of 8x?
16.
Yeah. In other words, they trick it up a little bit. And they trick it up just enough that if you're not paying attention, you're liable to have made the mistake I made and answer 2. In other words, x is 2, but they're not asking for x.
This is the value of 8x.
Yeah. Number 5.
B.
Hold on. Yeah.
Strong negative association would be D.
Yes. The only one that even has a positive association is C. And that's because if you were to draw a line through the beginning and last points, you'd have a straight line pretty much. Whereas A, you couldn't even draw a line through those points. B, it would be more of a horizontal line. But D would be pretty much of a straight line with a negative slope. And that's what a negative association means. And notice that's also the same thing as an inverse relationship. In other words, if you look at D, as D gets bigger, little d, t gets smaller. And that's what happens when you have this relationship. Remember where I said an inverse is y equal k over x? Well, notice that as x gets bigger, y gets smaller. As x gets smaller, y gets bigger. So an inverse relationship is the same as a negative relationship.
Mm-hmm.
And that is a picture of this kind of a model. All right. We'll stop there. Let's see. Question 5 on the calculator portion. Okay. Cole, have a good week. I'll talk to you next week.
All right, talk to you next week.
All right. Bye-bye.
Bye-bye.